A light bulb without any reflector causes a diffuse distribution. Using a light distribution diagram like this circle can illustrate how big the room of light is within the distribution, measured in candelas. It is the circle around the source, you could say, of luminous intensity, the circle of luminous intensity. When you create a model of the room of light in three-dimensionality, it is called an illumination solid. You measure candelas with a luminance meter and then create a solid of how it would have looked if it was a room, the light will say. When we create a reflector of preferably aluminium, as in this case, light is reflected and redirected, concentrated and collected. A reflector creating a downlight like this creates a direct light distribution. This increases the amount of light at the spot the reflector is directed at. This concentration of light towards the colored materials causes more absorption and reflection of other wavelengths. So even if I measured with a spectrometer close by to this bulb and it showed how the CRI of red was quite low, CRI may not say much in this case other than that this light source do not emit a lot of the redder light. It emits more of the 600 nanometer yellowish light, as you can see in the spectral power distribution graph how it slopes down at the redder longer wavelengths. Even if it does not emit the redder light, it is still enough for the wavelengths to be absorbed and the red light to be reflected. The surface gloss material and texture and the pigment of the surfaces also play a role in this. Color rendering index cannot be used at saturated fawn colors. It is only used for white light. As the lamp closes in on the colored materials, for example, the red material absorbs the other wavelengths of the white light and reflects the red. Putting on a diffusive material on the reflector causes the light to transmit through this material and scatter. This reduces the specular effects and also the harsh shadows. The borders of the beam become diffused. The black material Vanta Black is completely matte and pitch black, but this paper is semi-glossy and this causes the paper to look white in the reflection. But as it is black, it absorbs different wavelengths and desaturates the light. A reflector lamp have a direct light distribution, this one of an angle of 36 degrees. The diagrams are just to demonstrate the phenomena. The angle of our light is from above. Most of these materials are a mix between matte and glossy, and this causes a diffuse scattering of the light since it is not specular. While specular materials such as this mirror-like plate reflects it more directly. And the specular crinkled foil causes a mixed situation where it is both scattered and reflected. Putting a big square aluminium reflector on the reflector lamp collects the light even more towards the colored surface, causing the absorption and reflection of wavelengths from a further distance. This one, just as the light bulb, without the reflector, have a diffuse distribution. This source is a bit more intense. Putting the ball into the square reflector. The border of the mark from the beam of the reflector lamp on the colored material became sharper and more square, while this of the ball, even when put into the square reflector, caused rounder, softer borders on the mark of the beam. A clear bulb causes more specular effects. Trying out a laser experiment on absorption and refraction, the bending of light. These are two water pearls, one green and one red. Even if the pigment is faint, you can see how the pigment in the green water pearl absorbs the red light, making the laser look very sharp at the borders. While in the red pearl, the red light is reflected in the red pigments, making the beam look spread out. The pigment reflects it. The red color of the Christmas cloth may amplify the red. As you see, it is redirected. If you point it downwards, it redirects the light upwards. It is called refraction. Using a diffusive screen, you can place a glaring light source at the other side and a plant in between. When you point the glary light source towards the plant, you can see the borders and contours of the plant very sharply. When it is a diffused light source at the other side of the screen, the borders of the image turns diffused and blurred, and you can see less of the plant. The closer the object and the light source is to the screen, the sharper borders. Glary light source on the other side of the screen, sharp borders of the contours. If you cast a light at a wall using a reflector or directed fitting, you can see how the light can go from having a sharp, clear border to using a wider reflector, creating an intense middle that softly, gradiently fades into darkness. The more directed the light is, the more concentrated it appears on the wall. Adding a diffuser removes the harsh borders, but it is still intense on the wall.